Hello everyone, my name is Sadia Bashar, and in this video I will demonstrate my Arduino based room monitoring system. This system measures light intensity, temperature, humidity and provides real-time webcam monitoring, all accessible via a Node-RED dashboard. I will walk you through the system's features, setup, circuit explanation and real-time demonstration, ensuring everything aligns with the specifications from my project brochure. This system is designed to remotely monitor room conditions and display real-time sensor data. Key features is that the LDR sensor that measures light intensity, DHT11 sensor monitors temperature and humidity, webcam, it provides live video streaming, and the Node-RED dashboard that displays real-time data and sensor logs. The goal of this project is to create an efficient and user-friendly environment monitoring system useful for smart homes, greenhouses, and industrial applications. Here you can see the connection details. There is the webcam and the sensors are added in the sensors were added in the breadboards before, but for better stability we put them into the prototype board. And here you can see the specifications over there, the mechanical specifications, and that the box is the printed box and the dimensions are given there, and all of the mounting and the operating temperatures are specified over there. Also the electrical specifications about the operating voltage and how much is the power supply, and also the product demonstration is also given into the into as a YouTube video. It is linked there, and you can see the web display over there in the middle of the brochure. There the first one is the temperature, second one is the humidity, third one shows the webcam, and the last one is the measures the light intensity, and the last one measures is the measurement of the box. As you can see over there is the package details. Here for running the simulation, here you can see use of Arduino in monitoring systems is various because its use can be used for data collection, IoT applications, flexibility because this is an open source library, so it supports a wide range of sensors and modules. Also for Node-RED visualization, it is easy for integration, and also it has real-time data processing. It supports the IoT protocols. It works well with MQTT, HTTP, and WebSocket for real-time data streaming. Also webcam for webcam integration, it's also good, but limitations, there can be some limitations because it cannot directly handle video streams. It can collaborate with platforms like Raspberry Pi to manage the webcam. Node-RED supports webcam integration to its dashboard, widgets, and third-party nodes for video streaming. Here you can see the inputs, outputs, and controller and the power supply too. This is for the system block diagrams, as you can see. So here is the system block diagram. It was drawn before at the beginning of the project. For that we needed power supply before, but now it can be directly connected to the our laptops or desktops. As you can see, all the sensors are connected to the Arduino, and the web display is the output. And the circuit design for the project is it was designed in the Tinkercad and in the Arduino. And here is the package details. It was the dimensions were this one before, but it was subtracted a bit because we used the proto board instead of the breadboard, and it was designed into the on shape. And now we will go to This is for the computer requirements and setting up Node-RED. As you can see, I'm using here the Mac as MacBook Air. So this is my specification over there, but you can install this one in almost every almost all kind of devices or desktops. Suppose Windows, Mac OS or Linux, and the RAM should be minimum 2 GB. Recommended is 4 GB. Processor 64-bit CPU and Node.js, the latest LTS version. So here I had previously run the Node-RED to double check my dashboard. So here I will write the Node-RED to see check that my dashboard come up again. So as you can see, it was disconnected before and now it's connected, and I will press here the deploy, and I can see the user interface website. So before that, let's check the COM port specifications. There you can see the 9600. So it was recommended for this one, for this Arduino. So there is the gauges and all of the dashboards nodes for the project. And this one I splitted up the dashboard, so I wrote the code over there. And here you can see the dashboard over there. So this is how I operate the Node-RED dashboard over here. That's how we did it. This part shows the circuit explanation and wiring. This was that I did in the Tinkercad. Now I will explain the circuit connections and how each component interacts with the Arduino. Hardware components: Arduino Uno, LDR sensor, DHT11 sensor, webcam. This one's picture was not available in the Tinkercad, so I will show you this in the in real time circuit. And resistors and jumper wires, that was used for electrical connections. Now let's check the circuit in the real time. So here is the circuit over here. So now you can see all of the sensors over there. That's a light sensor. That's one pin is connected to the 5 volt via 1k resistor. Other leg is connected to ground, and middle connection to analog input on Arduino. And the DHT11 sensor wiring, the voltage is grounded to 5 volt. Data pin to digital pin 2, that will show the readings into the dashboard, and the ground pin is to the ground. And you can see the webcam setup. You can check the webcam setup here. I have made a hole over there, and it's connected to the USB port over here because my MacBook doesn't have the USB port, so I used the USB port to C converter. The webcam is connected to the USB to the computer, and the streaming is handled by the Node-RED dashboard. So with everything wired properly right now, we can power up the system and see it in action. So here is the dashboard over there, you can see right now. And that's the Node-RED. Here is the Node-RED dashboard demonstration. Now I will start Node-RED and show how sensor data appears on the dashboard. So it's connected to there right now. And let's test the DHT11 sensor first. So if I hold my hand over there with the sensor, and then you can see that it's increasing. The temperature is in and humidity both are increasing. See, it has increased to 27 degrees Celsius to 30 degrees Celsius. Now the light intensity sensor. So if I try to adjust the light intensity, so it fluctuates. You can see if I try to close the lid of the box, project box, then it starts to like fluctuates, and it increases whenever I open the box. Here is my project demonstrated by other people. So here is a friend of mine. She will test the system there right now. So as you can see, we both can be seen in the webcam dashboard, and she is trying to he's trying to take the temperature sensor in her hand. I told her to cover the hand with cover it, and then like you can see the temperature is increasing over there right now. When she's trying to blow hot air on it, so it is increasing. And here you can see she is waving for the webcam feedback. You can see her, and so we can monitor anything. Finally, we will test a light intensity sensor. So here she has a torch in her hand, and we are trying to increase or decrease the light intensity. So you will be able to see that the dashboard has will also fluctuate for the light intensity. And you can see that is increasing. uh, Real world applications and benefits. For example, smart homes, automated climate and lighting control. This system can automate lighting and climate control in smart homes. Example, if the LDR sensor detects low light, the system can turn on room lights automatically. If temperature exceeds a threshold, the air conditioning system can be triggered. Moreover, for greenhouses, for monitoring plant growth conditions, this system is useful in greenhouses where maintaining optimal light, temperature, and humidity is critical for plant growth. For example, if humidity drops, the system can activate misting systems to maintain proper moisture levels. Moreover, industrial use, for workplace safety and monitoring, industries need monitor temperature and air quality to ensure workplace safety. For example, in warehouses storing temperature sensitive goods, this system can send alerts when conditions go out of range. One major challenge was integrating the webcam feed with Node-RED. I also had to reduce sensor noise for more accurate readings. To conclude, uh, this concludes my demonstration of the Arduino-based environment monitoring system. This project showcases how we can integrate sensors, microcontrollers, and IoT platforms for smart monitoring solutions. If you have any questions, feel free to leave a comment below. Thank you for watching.